Can the secrets of the universe be solved with a single equation? Could one formula explain everything? Is it possible that a single law governs the entire universe? An equation that explains everything, from the Big Bang to black holes, from galaxies to atoms. This dream, which scientists have pursued for centuries, is known in the world of physics as the theory of everything. And it's not just a scientific goal, it may also hold the answers to the deepest questions of existence. Today, we have two major theories that help us understand the universe. The first is Einstein's general theory of relativity, developed in 1915. It explains gravity, successfully predicting everything from planetary motion to the collapse of stars. It is unparalleled in explaining the large-scale structure of the universe. The other is quantum mechanics, which rules the world of subatomic particles. Electrons, quarks, photons all obey quantum rules. But these two theories operate at opposite extremes of the universe. While general relativity governs the curved fabric of space, quantum mechanics deals with the uncertain behavior of particles. Unfortunately, when combined, these two frameworks collapse. For example, in the center of a black hole or the beginning of the universe, applying both at once becomes impossible. This contradiction was the great puzzle Einstein tried to solve in the final decades of his life. He dedicated his last 30 years to discovering a single law that would unite these two theories. To him, nature couldn't behave randomly. God does not play dice, he declared, opposing the uncertainty of quantum mechanics. His goal was to create a unified field theory that would unite all the forces of nature under one roof, but he died before achieving it. Einstein's quest evolved into what we now call the theory of everything. This theory aims to explain the four known fundamental forces: gravity, electromagnetism, strong and weak nuclear forces, within a single framework. And it must do so consistently, both on large cosmic scales and at the atomic level. At this point, physicists began to propose new solutions. One of the most notable is string theory. According to this theory, the basic building blocks of nature are not points, but tiny vibrating strings. These strings vibrate in different ways to form different particles. One vibration creates an electron, another creates a photon. This theory attempts to bring gravity into the quantum world. In fact, some versions even suggest that the universe has 10 or 11 dimensions. But unfortunately, string theory has yet to be tested experimentally. Another candidate is loop quantum gravity. This approach argues that space-time itself has an atomic structure. Like energy, space and time are also made up of the smallest indivisible units. This idea seeks to provide deeper understanding of black hole centers and the very early universe. Yet, despite all these efforts, we still don't have a confirmed theory of everything. Because the effects these theories predict appear only at the smallest scale in the universe, the Planck scale. This is the limit where time and space lose their meaning, and it is trillions of times smaller than a proton. At such scales, observation with today's technology is nearly impossible. Moreover, we know that 95% of the universe is made of dark matter and dark energy, yet we still don't know what they are. This ignorance prevents us from completing the full model. Another barrier is mathematics itself. These theories are so complex and multidimensional that our current mathematical language often falls short. Perhaps we need a new kind of math, or even an entirely new way of thinking to grasp the nature of reality. Still, science continues this pursuit. The James Webb Space Telescope observes the early universe. The Large Hadron Collider at CERN explores unknown particles. Artificial intelligence helps us detect new patterns in massive data sets. Each new experiment brings another piece to this cosmic puzzle. Maybe the theory of everything is more than just an equation. Maybe it's the key to understanding the structure of reality, the nature of time, and even consciousness itself. Because to understand how the universe works is to understand who we are. And maybe one day, a single equation will unlock the secrets of the cosmos. When that day comes, we may not only look deeper into the stars, but also into ourselves. And maybe that equation won't just define the universe, it will define us.